The very mention of the 2026 Tesla Model 2 and its revolutionary aluminum-ion battery signals a major shift in the landscape of electric vehicles, one that carries implications certain global competitors would prefer stay hidden. Elon Musk has subtly pointed to the fact that Tesla vehicles are not only cutting-edge in performance but are statistically the safest on the road. A fact even some Tesla employees might not fully grasp. This isn't mere opinion. The data is irrefutable. Safety, especially related to batteries, has long been a major issue for EVs, particularly the risks of fires and explosions stemming from lithium-ion technology. That stops now. Today's revelations build on past insights and take the conversation further into what could be the most transformative battery innovation of the decade. As the truth behind these developments unfolds, viewers are invited to witness a future Tesla is shaping, one that may finally provide peace of mind alongside sustainable technology. Imagine pulling your Tesla into the garage at night, plugging it in, and heading to bed without an ounce of worry. For many, that comfort is currently missing due to the frightening track record of lithium-ion battery fires. Yet Tesla's aluminum-ion advancement aims to return that safety. It's not only about quicker charging or more efficient energy, it's about restoring the sense of security for families across the world. Consider the reality Americans face today. In 2023, the U.S. saw over 260 incidents directly caused by lithium battery malfunctions. Dig deeper, and it gets worse. In just New York City during 2022, more than 200 such fires occurred, injuring around 150 people and killing 6. That figure marks a dramatic increase from 2021. Municipalities have taken notice. Some areas in New York and San Francisco have begun implementing bans or heavy restrictions on large residential battery setups. Fire departments themselves have expressed more concern about lithium batteries than even gasoline, an alarming signal that this problem is more than just technical, it's existential. Tesla's aluminum-ion batteries, however, approach the issue from a completely different angle, ditching the explosive liquid solvents that make traditional lithium-ion cells dangerous. These new batteries use a stable, solid polymer infused with aluminum salts. Their thermal endurance reaches levels far beyond what we're used to seeing. Lab tests confirmed that they remain stable at temperatures over 572 degrees Fahrenheit, a figure 3 times higher than what lithium-ion cells can safely handle. But what really sets them apart is what happens during failure scenarios. In lithium-ion systems, when a cell fails, it releases oxygen from the cathode, essentially fueling any fire. The aluminum-ion version doesn't behave this way. Even in extreme conditions, the cathodes in Tesla's batteries don't release oxygen, cutting off one of the primary accelerants for fire outbreaks. This fundamental design difference is like switching from gasoline to sand when trying to stop a blaze. Tesla's internal tests, some of which were part of early documentation filed for Underwriters Lab certifications, further validate these breakthroughs. One such test involves deliberately puncturing a battery cell with a nail. While lithium cells can explode or spike to over 600 degrees Fahrenheit, the aluminum-ion prototypes only saw a 5 degrees Fahrenheit temperature increase. That's more than a performance upgrade. It's the difference between a near-death incident and a minor inconvenience. These innovations go beyond chemistry. Tesla incorporates microfuses that isolate overheating cells instantly when they cross the 176 degrees Fahrenheit threshold. The battery casings themselves are layered with ceramic insulation, rated for up to 20 degrees Fahrenheit, preventing single-cell failures from impacting the entire pack. Even the internal cooling systems are designed to redirect thermal energy away from adjacent modules. The total engineering approach is built to detect, isolate, and contain issues before they escalate. Because of these innovations, places that had previously limited or banned home battery systems are starting to rethink their policies. Tesla has already begun submitting aluminum-ion-based energy storage systems to major regulatory bodies, such as California's State Fire Marshal and New York City's Department of Buildings. These new systems are being reclassified as not, which removes former barriers to their installation in densely populated urban areas like basements, garages, and apartment complexes. That change could also impact homeowner insurance policies, as insurers are beginning to explore safety-based discounts for customers who use aluminum-ion energy systems instead of lithium-ion packs. Tesla's confidence in the safety of its new batteries is further bolstered by the results of extreme tests conducted at their Sparks, Nevada facility. In late PA, engineers exposed the aluminum-ion batteries to prolonged heat -500 degrees Fahrenheit for Y minutes with no ignition, smoke, or combustion. Even under direct short-circuit conditions, the heat output remained low and stable, with the system triggering automatic isolation measures at just 140 degrees Fahrenheit. Perhaps the most compelling data comes from the full battery pack crush tests, scenarios that often produce flames and destruction in traditional lithium packs. Tesla's aluminum-ion versions simply absorb the impact without erupting into flames. The practical implications of this are massive. For those worried about EVs catching fire in their garages, this advancement offers not just reassurance, but statistically grounded security. Yet, the innovation doesn't end with fire safety. Tesla is also targeting the massive problem of battery recycling, a challenge that has plagued the EV industry for years. Anyone who's seen a decommissioned lithium battery knows how problematic they can be glued together in massive rock-like formations that are nearly impossible to separate without destroying the internal components. Because of this design flaw, when one cell or module in a lithium pack fails, the whole thing often ends up as hazardous waste. EPA data from 2023 shows that only 5% of these lithium battery packs are fully recycled. The process involves shredding, burning, and chemically treating materials at great environmental and financial costs up to $4,000 per ton. In some cases, making matters worse, much of this waste gets shipped to processing centers overseas, primarily in China, where it becomes someone else's problem. Tesla's new battery architecture is tackling this. With a modular approach that flips the equation, instead of gluing cells together into permanent structures, the aluminum-ion packs use mechanical fasteners. Each module can be unbolted individually, making automated disassembly viable and inexpensive. Tesla has filed documents showing prototype packs that can be taken apart in under 18 minutes using machines, a process that preserves cell integrity and avoids contamination. Even structural components like bus bars and cooling elements lift out cleanly, allowing for precise and controlled recycling. This method reduces waste, increases recovery rates, and avoids the destructive methods used in today's lithium pack dismantling. And then there's the material itself, aluminum. Unlike rare metals used in lithium-ion batteries, aluminum has been recycled efficiently in the U.S. for decades. The Aluminum Association notes that 75% of all aluminum ever produced in America is still in circulation. The energy savings are extraordinary. Recycling aluminum requires just 5% of the energy needed to extract it from raw ore. Tesla's pilot facility in Nevada is already seeing recovery rates above 98% for aluminum-ion battery materials. This means that when a Tesla Model 2 battery is retired, most of its aluminum can go straight into making the next generation of vehicles. It's a closed-loop system that gets cleaner and more efficient with every cycle. Tesla's partnership with Redwood Materials also plays a crucial role here. Redwood, founded by Tesla's former CTO, J.B. Straubel, specializes in advanced battery material recovery. By 2026, they expect to process 60,000 metric tons of material annually using clean hydro-based techniques. Their aluminum-ion recycling rates over 95% for aluminum, 90% for copper, and 85% for lithium surpass anything currently in widespread use. The associated costs are also much lower, thanks to aluminum's abundance and simple purification process. Compared to today's standard lithium recycling, Tesla's new process is expected to be 40% more cost-effective per kilowatt-hour. But Tesla's strategy doesn't stop at recycling. They're designing batteries for reuse before recycling even becomes necessary. As EV batteries age and fall below automotive performance standards, typically around 80% capacity, they can still function reliably for energy storage in homes. A single 80 kilowatt-hours battery removed from a Tesla Model 2 could provide power backup to a household for 2 to 3 years. This significantly extends the useful life of every battery before it needs to be broken down into raw materials. Tesla has already filed patents for retrofitting retired EV battery packs into Powerwall-style systems. These modular, second-life systems are easier to install and benefit from the cooler and more consistent operating characteristics of aluminum-ion technology. They also degrade more slowly, meaning they can serve in stationary roles for many additional years before reaching the end of their life cycle. What this amounts to is a total shift in how we think about the life of an electric car battery. A single battery might serve 15 years in a vehicle, 5 more in home storage, and then go on to provide raw material for new batteries, adding up to a total useful life of 20 years or more. That sort of longevity, combined with easier and cleaner recycling, is what finally makes the economics of sustainable transportation work.